Assalamualaikum dan selamat sejahtera. Alright, now we move on to the next one. Application of the refraction of wave, right? So the waterfront of seawater will follow the shape of the shore when approach the shore. So we discussed in first thing, right? Just now. So the shape of the waterfront will follow the shape of the shore. Okay, so this is what we get from shallow. Okay, so the water will travel from deep to shallow. Here, from deep to shallow. This is deep region. Going to shallow region. Okay, what happened is the speed of the wave decrease. So speed decrease. When speed decrease, the water wave refracted towards normal line. So it will refracted toward normal line, and we have something like this. So they will make the line follow the shape of the coast or of the shore. Okay. Alright, next. Now the question also may ask the water in bay calm compare at the cape. So this is location of a coast. Sorry, a bay. So bay normally we have a picnic or we always the shore is calmer, so it is a very suitable region to swim and so on. Okay, so here is the at the shore, so the water is calm. Ada a small ombak kan. Okay, it's okay. Alright, now so how to answer this question? So the water in the bay comes, okay, it is because the depth of water varies through across the area of the bay. So it's coming from deep to shallow. So depth the different, therefore the speed also will different. But what happen next is the energy of the water will spread to a wider area. So the energy will spread to a wider area, something like this. Okay. So here is okay. Okay, wave coming here. Okay, here is the wave. Okay, wave, and then when it come to the smaller atau shallow, it will spread out to area like this. So it will come something like this, right? So, okay, smaller. So this will the energy spread out. When the energy spread out, it will decrease. So when it decrease, the amplitude of the water wave near the bay is low. So spread out means energy is spread out, means the energy will become lower, and amplitude of the wave also will become lower, and the water is calm. Alright, so that's how we get the answer for why the bay comes. Okay, now we have another region where is what we call cape. In Malay we call tanjung. Okay, this is the wave. So it has a high wave, right? So the most of energy is converged at the cape. Okay, we go back here. Okay, let's say you have cape. Which one? As we can look at from this diagram. So this is the area at the bay, right? So it will spread out like this, something like this. Okay. But here, what happened is the wave here is converging, right? So means the energy is focused, is converged here. So when energy is converged, so means that most of energy is focused at this area. Okay, so that's why the cape has a high wave. Okay, that's the reason. High wave because of a high energy. Why you get high energy? Because the energy is converged. According to the wave to the location of the wave. Okay. Okay, now we move on to the next one. The sound can be heard clearer over a longer distance on a cool night compared with a hot day. Okay, so the sound can be heard clearer over a longer distance on a cool night compared with a hot day. Okay, so now we are going to talk about sound wave. Okay, sound wave. What we have here, sound wave travel faster in warm air than in cool air. Warm air, the air molecule has high temperature. Temperature in warm air is greater, so air molecule gain more kinetic energy and move faster. also warm air is low density. So when low density air molecules are further to each other, so they will move faster, okay, rather than cool air. Cool air molecules have low energy, so move slower, okay. Okay, so now let's look explain why sound cannot be heard over a longer distance on a hot day. Okay, so we look at here. Hot day, the level of okay, the air near the land always hot, so it become warmer. So when you approaching up, going up, the air will become colder, cooler. So we have cool. So hot air near the ground, cool air above the ground. Okay. So as we know that warm air is dense, but cool air is denser. So the air molecule will travel faster in warm air than cool air. Okay, so what happened here is on hot day, the layer of air near the surface to be warmer. Okay, sound travel from hot to cool air. Okay, on hot day, sound travel from hot to cool air. So the speed of sound decrease. Maknanya warm air faster. When you go upward, it will become cooler. Cooler means we become slower. So the speed of sound decrease. When the speed decrease, so it will refract towards normal line. So we can see here, okay, towards normal line. Okay. You can draw like this. So this is the boundary. So this is the let's say apa ni sound from warm air. So it will go. Okay, this is hot. Okay, here is cool. Okay, cool air, and we draw a normal line. So this is the normal line. Okay, normal line. So the speed increase. Sorry, the speed decrease from hot to cold, right? So it will towards normal line. So when we travel towards normal line, it will move away from the earth. So it will move outward. Okay, outward. So when you are here, the observer here can hear a sound which is weaker. Okay. So this is during the day. Okay, I hope you understand. Okay, now explain why sound can be heard clearly over a longer distance on a cool night. So cool night, so different. So what you have here is at night the ground cools, air layer near the ground is cooler. Okay, so let's say we have the boundary. Here is cold and here is hotter. Okay, where you go outward, it will become hotter. So the sound wave from cool area. So this is normal line. So we draw a normal line. So it will travel from cool to hot, and the speed of sound increase. So the speed of sound will increase. So we know that when the speed increase, it will refract away from normal line. So away. As you can see, so when you come away, it will approach towards the earth. Okay, it will approach towards the earth, something like this. Okay, and as an observer here can hear sound which are louder. So this is how we explain why sound can be heard clearly over a longer distance on a cool night. Okay, all right. Okay, so let's look at for the last part. Example 1. So we are going to show example of question solving problems. Okay, so example, a plane wave with velocity 4 cm per second moving from a shallow region to a deep region. Calculate the frequency and speed in deep region. So smaller region, shorter wavelength, and deep region has a longer wavelength. Okay. Right. So we take information. Lambda 1 equals 1.5 centimeter. Lambda 2 equals 4.5 centimeter. Now we use the formula V1 over lambda 1 equals to V2 over lambda 2. So we put it 4 over 1.5 equals V2 over 4.5. Okay, that's the formula. So we have the formula we solve and we get V2 equals to 12 centimeter per second. So it should be greater in the deep region. Okay, so this is how you get the answer. Okay, example 2. The speed of water wave in shallow area and deep area is 4 meter per second and 9 meter per second respectively. The wavelength in shallow water is 2 meter. Again, we use the formula. Line 9 over lambda 2. This is deep region, right? Deep region, 9 over lambda 2 equals to 4, which is 4 meter per second, which is 2 meter. And we solve, we get lambda 2 equals to 2 times 9 divided by 4, and we get 4.5 meter, right? So it should be a simple question here. Okay, so this is another example. So we have what ripple tank, and then you put a perspex block which has different depth, right? So here is X. Okay, here is X and Y. So the region X is deeper than region Y. So X is deeper. And we have the wavelength in region X longer because the deeper, the faster, and the longer the wavelength. So deeper the water, the longer the wavelength of the wave. Alright. Okay, another question. So this is the diagram. So I have two region P and Q. First question, which region is the shallow region? Why? Okay, so you think which one? So when we look here, we look at the wavelength. So we look at which has shorter wavelength or longer wavelength. Repeat that. So if the question asks you shallow region, means you have to look at the shorter wavelength. So Q lah. So Q is the shallow region because the wavelength are smaller. Okay. Compare the speed and frequency. So the speed follow the wavelength, follow the depth. Okay. Speed of Q is smaller than speed of P, but both have the same frequency. Speed P larger than speed in Q, but have equal frequency. Alright. So that's all for refraction of wave. Okay, so we continue with the next topic. Okay, bye. Assalamualaikum. Okay.